Hi guys, so today I'd just like to make a video and talk about how I was able to design and make my drone payload release mechanism for my Xiro Xplorer here. So the Xiro Xplorer is it's a drone with GPS, not unlike the Phantom 2 and 3 series, and so it's very much a enclosed unit. It's modular and pretty well designed. So in terms of options for controlling a payload release mechanism, I really wanted to do it with the controller so that I could hit a switch and be able to open and close a little motor that could release a payload. In my case, I'm keen to go fishing, so release a bait onto a fish's head. So the remote's it's got some great features, but most of them are not really suitable for being able to release a payload. The things that you can control are obviously the drone itself, so you can go left, right, up and down, and there's a number of videos online about how you can make a very simple release device with some blue tack or a closed peg or a coat hanger bent in a way such that if you turn the drone this way or that way, it'll physically release something. In my case, I was keen to do something a little bit more controlled, so I wanted to be able to hit a switch basically. So the options were that on the remote there are really only two things you can control other than the drone itself that I could figure out. First is the camera, so you can control the pitch of the camera. So if I move the right scroll wheel, I can turn the camera to face down 90 degrees or up at the horizon. And in theory you could hook something up to that so that it could release. Problem is, this motor's got absolutely no torque. If I just touch it, it just gives up, like it's just flimsy. So it's really, this gimbal relies on a perfectly balanced camera and system, so the motors just have no ability to carry any load. And the other option, which is the one that I went with, is to control the LED brightness. So on this particular drone with the left scroll wheel, if I pull it down, it'll dim those lights out and to the point where they turn off, and then I can turn them back on again by pushing up on the scroll wheel. So I decided to utilize this little feature to trigger the release mechanism on the motor. So I'll put this aside, turn this off, and I'll take you through the design of what I came up with. Sorry. Alright, so here's a schematic of the design. So I'll go through it bit by bit. So basically, to start with, it needs to be powered, and in theory you could power this from the drone battery itself. This particular drone has a 3S LiPo to control the drone, but it's all very integrated, and I didn't really want to drill holes in the drone or solder wires onto the battery terminals or anything. So for me, the simplest option was to make an independently powered device. So I decided to use a 1S small battery to power it. So something like this here, it's 3.7 volts with a maximum at full charge of 4.2 volts. So that's going to be my control power, and then I'll hook that up to a switch here, so something like this, and that's just so that I can pull the battery out and recharge it on a charger, or turn the device off if I need to. And then basically, so the system's going to be controlled by an Arduino little controller, an Arduino Nano. So that requires, it needs 5 volts to be powered through the USB plug, or it can be powered with, I think it's something like 6 to 12 volts through the VCC pin on that particular controller. So because I was using a 1S battery which had a lower voltage than the specs on this Nano, I needed a way to get regulated 5-volt power to drive this. And so what I'm using for that is a 5-volt regulator. So basically that takes the power from the battery, goes through the switch, goes into one side of the regulator. So that's going to be less than 5 volts going in, and coming out will be 5 volts regulated. And there's not much current that these things draw, so it doesn't have to be very, very gutsy. And I found one on eBay which I bought. It's about the size of your thumbnail, and you can see here those are the positive and negative going in on one side, and on the other side is the 5-volt fixed output. Yeah, so this claims it can drive 2 amps, so more than what I need. And then so the output of that basically powers the Arduino, and I just used the USB plug to do that, so I can unplug the Arduino if I need to. It's basically USB has 4 wires. You've got your positive, which is normally red or pink or something, and then ground, which is normally black, and then you've got 2 data wires which you don't have to worry about. So to power this, all I did was took a micro USB plug, snipped it, and used that to solder onto the outputs of the 5-volt regulator. Alright, so that's the power. And then in terms of controlling the drone, so I do not profess to be an expert in electronics. I'm quite far from it. I've scoured the internet and I found some other circuits, and I've basically adapted those to what I want to do here. So this little symbol is a light dependent resistor or photoresistor, and that is what's going to sense whether the LEDs on the drone are on or off. And so that's basically a variable resistor. So they look like this. So they're very small, and on the front face of them, sorry, I'm having trouble getting this in focus. There's just a little sort of, sorry, maybe if I do this. There we go. That's just how they look on the front. Pretty simple, and so that's sensing the light and outputting different resistance depending on the light. So just to demonstrate, I've got one hooked up here to a multimeter. So this is my light sensitive resistor, and here's my multimeter. So I'll set that on resistance like that, and so you can see in the daylight it's currently registering this particular one about 1.4 kilo ohms. If I just put my finger on that, you can see that changes to 5, or then if I completely make it dark, it's gone all the way up to 30 kilo ohms. So you can see that can act as a trigger to open and close your servo motor if you turn the LEDs on or off. So I'll show you how I hook that up to the drone in a second. I'll just finish off here. So you also need a 10 kilo ohm pull down resistor. So that's you can look up pull down resistors on the internet if you want. So just a standard 10 kilo ohm resistor that just goes in between the analog 0 and ground here. And lastly, you need the motor, and so that's what we've got here. So this is basically the release mechanism. You've got here a little servo motor, and that's enclosed in a little 3D printed housing that I didn't make or print. I bought it off eBay. So that just the motor turns. It can turn about 180 degrees, I think, and then that just, you know, opens and closes, so you can hook a little something or other in that little groove and it'll release it when you open the motor. So that's got 3 wires. It's got positive, negative, and a control for the motor to determine whether it's open and closed. So the control PWM wire goes to the digital out. So in this case, I've used D12 on the Arduino. And for the power, I decided to power it directly from the battery, so on the unregulated side. I was a bit worried that when the servo opened and closed, it would draw a bit of current and might cause the Arduino to reset. I'm not sure if that's founded, but at any rate, you know, the battery at 4.2 volts is perfectly able to open and close the servo. And to be safe, I put a 470 microfarads electrolytic capacitor in parallel here. So that's, you know, it looks like something like this. Basically, this particular one here, I'm using one that's maximum of 25 volts, so obviously that's way overkill. You know, probably 10 volts or something would be fine. Yeah, and that basically acts as a little, you know, battery, so that when the servo draws current, there's a reservoir that the capacitor's storing, so that you won't get too much of a voltage drop in the circuit. But you know, you could probably power the servo from the 5 volt side, and you'd be fine. Okay, that's about it for the design. In terms of other things you need, probably, you know, I haven't completely finished it yet, but you'll need some spare wire. I've attached it to the drone with some good quality Velcro. So this is the 3M brand, and it's sort of an interlocking type, pretty tough stuff. That will definitely be tough enough to hold the system in place. What else will you need? You probably need some electrical tape. You'll need a soldering iron, and probably a few bits and bobs. And the multimeter is pretty handy too. Okay, so I'll just pause this for a second. No, I won't. So basically, in terms of installing that photoresistor on the drone, so this is the only real modification that you need to make to the drone, is the photoresistor. So as you know, if you own one of these drones, there's lights on the bottom. Each arm has 3 LEDs, so 1, 2, 3. The ones on the battery side will flash, and the ones on the front side, so the 2 on the front, will stay on permanently, as far as I can tell. So I decided to use one of the back ones because it was closer to the battery, so I was able to use the battery top face to mount the servo motor on. So I super glued the face of this photoresistor to the top face of the one of the LEDs. This one here that is covered by electrical tape, and I just put a little bit of sticky tape in between. I just used some Kapton tape, so I didn't, so I stuck the Kapton tape onto the surface of the LED, and then I super glued the photoresistor onto the sticky tape, and then I covered it really thoroughly with black electrical tape, because you really need to make sure that it stays in the dark from this side. Otherwise, the sunlight will just cause your servo release mechanism to open. So really cover it up on all 4 sides, and with black electrical tape, make sure that no sunlight can interfere with the detection of the light from the LED. And so yeah, I physically snipped off the excess leads on this and soldered on some thin gauge wire, and then I routed that. And as my drone, which I bought second hand, had been involved in a crash, it was completely busted up, and one of the arms was a bit damaged here. You know, you can see the plastic case was kind of has been bent with a hard landing, and so I've just routed my wire through there. You could drill a small, you know, probably have to be a 2mm hole. This is hollow casing, and route your wire through there. You could leave this cap off and just have your wire, you know, coming out from there, or you could, you know, find some other way. Basically, you need to get the wires from the photoresistor outside the case, and that way you can attach them to your device. And that's all you need to worry about for modifying the drone, apart from sticking some Velcro onto the battery to attach everything. Alright, so in terms of what else do I need to mention? Yeah, in terms of putting it together, I just soldered it all together, and you know, I haven't fully sort of finished it, I guess, yet, but at the moment it's just the control circuitry. So in here is the Arduino, the plug, the regulator. Comes out to be about, you know, it's pretty light. The weight of the whole system is under 100 grams. I weighed it. So you've got that, and then you've got your battery here, which plugs into there, and then you've got your servo motor, which plugs into there, and then this plug here goes into the photoresistor. So I'll plug it all together and show you it in action when it's attached to the drone. Here it is hooked up to the drone. So on the top of the battery we have the servo motor here, and it's connected. It's just stuck onto the top. The release point here in the system is, you know, fairly central on the drone. So you want the connection point here to be close to the center of the drone as you can, so that the weight is underneath the center of gravity. But you just need to make sure that there's enough clearance between the yaw arm of the gimbal and the motor. You can see here that there's a bit of space there. Next to that is the battery. That's just stuck on with Velcro, and then the rest of the control circuitry is attached to the arm here, just with a bit of Velcro as well. So I turn it on with this switch, okay, and there's just a short delay of a few seconds, and then it is now controlling this. I can't open this anymore, it's been actively closed. So the lights are flashing, as you can see, so I'll turn those off, like that, and then the arm opens, and then once again, if I turn them back on again, it closes, and turn them off, short delay, opens. So the way to understand how this works is to look at the code. So in order to get the Arduino to know what to do, you have to upload a small section of code to it to understand how to integrate those signals. And that's the last thing I'll show you. So I'll get the drone out the way. Okay, so I brought the code up here, and I'm not even a beginner when it comes to writing code. I'm a complete hack. But this is what I wrote, and yeah, there's a fair bit of swearing involved in getting this to work, but I did eventually. It's a short section. I'll take you through it line by line. So at the start here, use the mouse cursor. You include the servo.h library that's got commands specific for controlling a servo motor, apparently. You define your servo motor and you give it a name. So in this case, I've called mine my servo. You then tell the Arduino where the servo is connected to. So we have it connected to pin A0. I then define a couple of sensors, a couple of integers here, so sensor value, which is the LDR sensitivity, a timer, so you'll see that in a second, and then the setup commands, which just run once. You tell it that you're attaching your servo, so that's the D12 pin. I've also got it to output the values that it's detecting off the LDR to the serial port. So that's what that is, and you can, so in other words, you can read off the this Arduino program here what the actual values are that it's sensing off the LDR. Here I'm just initially telling it to close the servo motor at the very start. Then there's a delay of 5,000 milliseconds, i.e. 5 seconds, and then it goes into this loop which cycles over and over, and this is basically, you know, where the money's at. So in essence, it's looking at what the sense value is, i.e. the photoresistor. If it's greater than the value of 200, so this is on the A0 pin, it's detecting a value between 0 and 1023, and basically if it's on, it's going to be a high value, somewhere around 1000, and if it's off, it's going to be a low value, like hopefully, you know, less than 50 or something like that. Mine was about 20, and that just depends on, you know, the brand of photoresistor you've got, and what the actual resistance is at the time. So if it's on, so if it's greater than 200, then you write to that serial file that it's on. Make sure the servo, it tells to close the servo, and it sets the timer to 0. If it's not on, so in other words, if it's less than 200 and at the same time timer value is less than 6, which means that it's recently gone off, then it says to increment the timer integer by +1 and have a delay of 0.2 of a second, and then it goes back to the start. So if that happens 6 times, so in other words, you know, if it doesn't detect the LEDs on after a period of, you know, 6 cycles through this, which equates to just a couple of seconds, then it will go to this, then the timer value will exceed the number 6, and it will instead go to this section of the code where it tells it to open the servo. So here is the command for opening the servo. So basically these servos respond to a number of different commands. You can either, there's a command to define what angle to set the motor at, or you can tell it to write in microseconds, which is the pulse that it's sending on that control wire, which defines the position of the servo. So and you can test this beforehand. You can plug it in and type in different numbers and see what position the servo ends up in. You know, typically, you know, around 2000 is completely one way, and you know, slightly less than 1000 is completely the other way. So mine's not going to either extreme of its rotation, but this was enough to open and close the mechanism for me. Yeah, so it opens a servo, and then it waits. There's another delay here, and then yeah, so it just cycles through this bit of code here with these 3 options. It's either LEDs on, LEDs are off but have only just been off, i.e. that, you know, they're in the process of flashing, or they've been off for a period of time, and it will open the servo. Yeah, so that's how it works. I previously made a short video showing the output of the serial port and the numbers that I was getting as it was flashing. So I'll try and dig that up. So we have drone on, lights flashing, photoresistor attached to one of the LEDs, which is in turn attached to the Arduino. The Arduino is monitoring the LEDs and it knows they're on or they're flashing. And so when I turn the LEDs off with the remote, it knows they're off and it opens the servo motor. Okay, LEDs going on, servo closed, LEDs going off, short delay, servo opens. But basically, that's the code, so you just have to upload, you plug in your Arduino to your USB port with the cable that comes with it, and upload the code, and then you're set to go. So that's how I did it, and yeah, let me know how you go with yours. I guess this, in theory, should work with any other drone that has lights that are controllable with the remote. I'm not sure if you can do that with the Phantom or not, but I'd be curious to hear if anyone's has any success there. Alright, cheers. Alright, here we go. Testing my new drone release mechanism. So, trying to do this one-handed. So that's locked in. Attached to 270 gram wrench. Alright. Let's see how she goes. So, armed. Rest my phone there. Fall down. Alright. One flying wrench. Alright, let's test it. Releasing now. Staying where it is. Sitting around. Okay, dropping. Alright, so that was the wrench that I just lifted, 280 grams. This is a 680 gram wrench. I don't think it'll do it. Let's give it a shot. Okay, armed. Not quite. Can't quite get it off the ground. It is off the ground. Let's drop that wrench. Alright. So, 680 gram wrench, can't quite get it off the ground.